Hi, my name is Cecilia Franck, and today I'm going to talk to you about nuclear physics. I'm usually much more of a humanities and arts kind of person, but I find nuclear physics really cool. So today I'm going to explain to you about hadrons. There are two kinds of hadrons. There are baryons and mesons. Baryons have 3 quarks, whereas mesons have 1 quark and an anti-quark. Hadrons exist very briefly, but there are 2 that exist for longer. These 2 are baryons. You've probably heard of them. Number 1, protons. Number 2, neutrons. Hadrons are made of these little things called quarks. Quarks were discovered in 1968 at the Stanford Linear Accelerator Center. Quarks have 4 fundamental properties: electric charge, color charge, mass, and spin. Those are some pretty complicated things, so I'll break it down. Electric charge is actually pretty easy. It's electric charge. For example, electrons are negative and protons are positive. Color charge is a little trickier. It doesn't mean that the quark is purple or anything. Actually, color charge is in reference to the 3 primary colors. It's called color charge because it's kind of like electric charge, except there's 3 options instead of 2. Mass can be defined as the amount of matter in something, but that's not a really good definition. The significance of the fact that quarks have mass is showing that it is, in fact, a form of matter, albeit a very small part, but matter nonetheless. Spin, in this case, is actually referring to rotational spinning, the same way that you can spin a ball or the Earth is spinning on its axis. Those are the properties of quarks. There are 6 types of quarks, each type being called a flavor. The flavors are up, down, strange, charm, bottom, and top. The only way we can see quarks is by using particle accelerators. Actually, the way we discovered them was by taking 2 hadrons and throwing them against each other and watching them explode. When they exploded, we were like, hey, what are those tiny little things? They were quarks. The fact that we thought of throwing hadrons against each other was pretty crazy. We still don't have a unified theory about how quarks work yet, but they're working on it. I don't know, I still think that the fact that we know they exist is really amazing. So quarks make up pretty much everything, and the discoveries we've made through quarks have allowed the field of nuclear physics to advance leaps and bounds. The discovery of quarks provided funding for particle accelerators across the world. This brought funding to the Stanford Linear Accelerator Center, advancement of the Fermi Lab in Chicago, Illinois, and the building of the Large Hadron Collider in Geneva. Thanks to the discovery of quarks, science has advanced faster than it ever has in the history of mankind. Some physicists theorize that there might even be particles smaller than quarks that we haven't even been able to see yet. This is causing the development of even new and even more advanced equipment. The subject of quarks have been discussed in everything from Dan Brown novels to YouTube videos. I'm just glad I can add to the pile. Thank you for watching, and comment, like, subscribe, and all that jazz. Bye!